Okay, so in order to help prepare for our test coming up, I wanted to go over some of the things we've talked about regarding domain, range, and functions. So on this sheet, I'm going to first look. I'm asked about the domain, the range, and whether or not this is a function. So there's three things I want you to be able to tell me. So in order to find the domain, those are the x values, correct? So the domain is the set of -5, -1, 3, and -1 is already there, so I am not going to list it twice. The range are the y values, okay? So the y values I have are 3, 0, -4, and 2. No repeats. Were there repeats in the domain? And the answer was yes. Remember, the repeat for this was -1, and I'm going to circle that because it helps me. If the domain repeats, meaning that there's an x that repeats, the answer to this question is no, because there's not a one-to-one pairing between domain and range. So let's try the next one. Okay, so for this one, the domain would be 0, 5, -4, and 9. Our range would be -8, 3, 3, and 2. Now notice, I don't need to write this twice in my set, okay? I'm going to ask my question again. Do any of the x values repeat? The answer is no. There is a y value that does repeat, but does that affect whether or not it is a function? No. So because no x values repeat, this is a function, and the answer is yes. Okay, let's try this next one. First of all, this is a discrete function. Discrete. Okay, that's the one that looks like freckles on your face. It's not continuous. So the domain would be all of the x values. If I needed to, I could write all of these ordered pairs to the right, and I'm going to do the first one like that, and I'm going to do it as a table just to give us a place to start. So this point right here is 0, -1, 2, 3, 4. 0, -4. I'm going to go from left to right. Then this point is -1. Let's see. I'm so sorry. Mrs. Golding, good thing you made that mistake, because I think that's a mistake that a lot of my students will make. So let's go x first. So let's go to the left. -1, 2, 3, 4. I apologize. And then I go up or down 0. Okay, so please learn from my mistake. So let's again do this point. -1, 2, 3, +2. So -3, +2. Let's go to the next point, which is here and here. So x first. 1, 1, 2, 3. 1, 3. 1, 1, 2, 3, 4, 5, 6. 1, -6, correct? And then this point, 1, 2, 1, 2, 3, 4, 5. 1, 2, 5. Those are my points. The domain is a -4, -3. These are the x values. 1 is listed how many times? Twice. That's important. And 2. Is there an x value that's listed more than once? Yes. The range is the y values. 0, 2, 3, -6, and 5. A lot of times you'll see these written in order from least to greatest. Okay? None of those repeat, nor does that matter for defining a function. Now, is this a function? There is an x value or part of the domain that repeats, so the answer is no. In other words, you could draw a line from here to here, from here to here, between those 2 points. And if I were to pass my pencil from left to right, I'm crossing 2 points at the same time. Okay, that's called the vertical line test. I made a vertical line and it connected some points. That means it's not a function. Let's check this one. This is continuous. Okay, so it's domain. So you can continue to write the ordered pairs in any way that you choose. You can map them, you can write them out, or you can do without. The domain, though, for this one, I'm going to use interval notation. Again, I believe this is what a lot of high school teachers prefer. So we are going to notice an open circle. Okay, open circles, we use a parentheses, and another open circle. Just to remind myself, a closed circle is a bracket. Infinity is always enclosed with parentheses. So my minimum x value, the one that's furthest to the left, is this. I'm going to take it down here to the x-axis and I'm going to bring it over. Okay, and again, this is where those colored pencils come in handy. And I'm going to bring this one up. This is the maximum value of my domain. Open, open, because my endpoints are open. And it is, the minimum value is 1, 2, 3, negative, comma, my maximum value of 2. Now my range is different. That's from the bottom to the top. So I'm going to bring those over here. Now, because it's touching here, we're going to call that closed because it does include that point. And then we're going to draw our line up to the maximum, okay, which is right here. Oops, it's open, right? You see that open? So I'm going to write from minimum to maximum, going from bottom to top is how my range is found. It's closed, so we're going to have a bracket on this side, negative 1, 2, 3, 4, 5. Negative 5, comma, starting at the, don't start down here, start at the origin. 1, 2, 3, 4, open, open. Is this a function? I can try a vertical line test. If I were to take my pencil from left to right, I am not crossing any 2 points. Okay, so there's no point where an x value repeats. Okay, they're all unique. So I'm going to say yes, this is a function. Okay, so this one, number 5, is in the shape of what's called a parabola, and we will learn about these more when we're doing quadratics. Now, for this one, the domain going from left to right is going to be quite large, because notice with these arrows, they tell me that this is going to go on forever and ever and never stop. So the domain, and again, I'm going to use an open bracket because I'm talking about negative infinity and positive infinity. Okay, another way to represent that is the R for all real numbers. Okay, so all real numbers, all x values are represented in this. Now the range, there is a maximum, okay, and our maximum we're going to close, okay, and going this way, it's going to continue, correct? So, right here. Now, when we talk about the range and we notate that, we always start with the minimum and go to the maximum. Minimum is the furthest down. Now, how do we define that? Going on forever in a negative direction? open, always infinity is open, or parentheses, comma, but it does have an end when you get to the maximum going up, and that is 1, 2, 3, 4, 5. And it is closed like that with the bracket. Is this a function? Again, all x values are unique. My pencil, when I move it from left to right, does not have any x values that would repeat. So this is a function. Yes. Okay, this one. The domain would be x values from here to here. And on this one, normally I bring it up to the x-axis because it's easier, but since it's crossing the x-axis, I don't want that to confuse you. So we're going to find the minimum value, and we're going to close this, and we're going to close the maximum value, and I'm just going to draw, see if I can get my hand to work, across here instead of bringing it up to the x-axis. So the domain closed at -2, closed at positive 1, 2, 3, 4. Okay. Now the range, I'm going to go ahead and bring this over here and not bring it to the y-axis, just because it's a little easier to see the minimum and the maximum here. So going from bottom to top, the range is closed at -1, 2, 3, and positive 1 is the maximum value, closed. Now, when I draw my pencil across, do you see correct from here to here, the vertical line test, we don't pass that test because there are 2 points that share an x value, and that x value is 1. All right, now we would have another set, right? That would be 1, 2, right? Here's this, 2, and 2. So this is not a function. The answer is no. All right, this should help you a lot as you prepare for our test coming up.